Good morning. So I was asked specifically to go over these three questions. Thank you for joining me, so it makes me feel like I'm talking to somebody, Kayla. I know I just was, after trying to get, of course, the hover cam to function. Hi, Hal. If you have questions, just type them in the chat. I just checked my email and didn't see any new ones. Hi, Molly. And I also want to apologize if there's interruptions or if you can hear the banging in the background. I know my microphone picks up a ridiculous amount of things, but I had a surprise bunch of guests this morning early at 7:45 while I was running, and I have roofers here right now. Hi, Julie. So there's a lot of banging, and hopefully you don't hear it as much as we do. We had wind damage, and thankfully I'm getting my roof replaced. It's just everything seems to want to happen all on the same days. So these three questions, it was practice 69, number 16, and then practice 70, 14, and 24. So if you have not, and I only saw maybe one or two people, hi Laura, a couple people, I only saw one person ask a question. So again, if you have any questions, please type them in the chat, and I will find the PDF and we will answer those questions. So the first one was number 16, and this was SR7, 19 degrees and 28 degrees. So first off, we want to see that this top one is a right triangle. So I've got to figure out how to get R and S, but what I can't forget is that I do have this other right triangle here. I did not do this problem yet, but I do know that this whole angle here then is going to be 47 degrees. And if that entire angle is 47 degrees, and I'm trying to solve for, let's say, this side. That side is X, and that would also be R plus 7. The issue would be, then how do we figure out these? So I'm wondering if I copied the problem correctly, because maybe that's the bigger issue. I, of course, wrote this down at like 12:30 something last night, and of course didn't look closer at it, because that would have been smart, right? Nope, that's the whole question. All right, so, Well, that one we're going to put off because I don't want to waste your time. If for some reason you think you guys already have it figured out, please give me a suggestion. But I'm going to jump to 14 and 24 because I don't want to just sit and work on that one. I don't want to waste your time. I'm going to go to this one, and I apologize for that because I know it'll come to me, but let's start with this one first. Down here, you can see that we have 58 degrees and 32 degrees, but this time, thankfully, we have another side that's known. So in this first triangle, I'm going to highlight it in blue. we're going to go ahead and find V and X. I don't really care which reference angle you use. I'm going to use 32 just because. Here's opposite, adjacent, and hypotenuse. So in order to find X, I'm going to use cosine of 32 is going to be adjacent over hypotenuse. And cosine of 32 is 0.848 over 1. And the nice part is when we cross multiply, we are going to get X is about, we're just going to multiply that big decimal by 17, and we end up with about 14.42. I'm going to end up using that value to find W and U, but let's go ahead and find V. That's going to be sine, so sine 32 is going to end up being V over 17. Sine 32, 0.5299 over 1. And we're going to just multiply again by 17 when we cross multiply. We end up with V is about 9.01. So now I have to use this 14.42 in order to figure out this triangle. The one on this side only has the 67 degrees labeled, so we're not even going to waste our time with that 23 degrees in there. Here is still our adjacent side, opposite, and hypotenuse. So what's going to end up happening is both of the new equations that I set up for proportions has to use adjacent. So we're going to end up with cosine and tangent for these two. So cosine of 67 is going to equal 14.42 over U. And cosine 67 is about 39.07. We bring down that fraction, and then now when we cross multiply, we do have this, this decimal times U is 14.42. So we are going to have to take that 14.42 and divide it by our cosine of 67. So 14.42 divided by, second answer, and we should have U is about 36.91. The last one we're going to have to work with is tangent. So tangent 67 is going to equal opposite, so W over adjacent, and there's our 14.42. So tangent 67, just to set up my proportion, and W is going to be approximately, so times 14.42, and that's going to be about 33.97. So the nice part with this is it was just a lot of steps, but for the most part, we were just labeling and solving. All right, so 24 was the last one that was asked about, and it was a two-part question. It did say that, and apparently on this worksheet, it says that I will tackle number 16 on practice 70, yes. So in number 24, it did say that to code is 75 degrees. I'd be interested, honestly, to see if that's true outside. I have 5 different ladders leading to my different roofs, so that's interesting. And it just wanted to know how far away this guy was from the building. So here's our opposite, hypotenuse, and adjacent. And when we work this one out, because we just really care about the adjacent piece, we are going to use cosine. So this one is cosine 75 equals adjacent over hypotenuse. And then we will do cosine 75, enter. Create our proportion, and again, this one's an easy one. We just have to cross multiply, so times 20, and we end up with 5.18, or however they ask the answer to be written. In the next question, I believe it was asking how far should its foot be placed if it wants to reach that 36. So we're still talking about our x value down here again. So it says how long should the ladder be in order for it to reach? So we need to now figure out how far our ladder is. And then it wants to know how far should it be placed. So we're going to have to do two problems here. One being very similar, where we do have our opposite, this time given our hypotenuse that we're looking for, and the adjacent side. Uh-oh. Hopefully they plan on replacing that. Siding just fell from onto my window. So for the ladder, we're going to use sine, because that's opposite and hypotenuse. So sine 75 is opposite over hypotenuse. So sine 75 in the calculator. We're going to cross multiply, which means we are going to have to divide. So 36 divided by that answer. We figure out x has to be about 37.27. So our ladder is going to have to be just over 37 feet long. And then how far away, that's going to be tangent. So tangent of 75 is opposite over adjacent. So tangent 75 is about 3.73. And again, when we cross multiply, we're going to have to do one extra step. So 36 divided by that answer, and we find out y is about 9.65 feet. All right, so then let's make sure I get the right one for Julie. Julie wanted to look at number 16 on practice 70. All right. So number 16 on practice 70. We have our 2 radical 7 as our hypotenuse, 4 as one of the legs. Here's P, R, and Q. And it says find the measure of each acute angle. So what we want to know is the measure of angle P and the measure of angle Q. And it wants us to round the answers to the nearest tenth. Okay, so it doesn't really matter, again, which one you start with. as long as you give yourself a reference angle. So we're going to start with angle P. And that means here is my opposite side. Here's the hypotenuse. Here's adjacent. And in order to figure out the measure of angle P, we're going to use the two numbers they give us, which is opposite and hypotenuse. So sine of our angle is opposite over hypotenuse. Now here is the situation where I said in our calculator, because we are going to do our inverse sine, here is where that division bar is what we want to use. I do suggest, and again, I don't suggest plugging it all in parentheses. If you miss a parenthesis, that could be difficult. What I would suggest is figuring out what 2 radical 7 is. So the first thing I'm going to do is do 2 radical 7 and push enter. And that gives me that decimal. Now again, because it gives me all the decimal places, I don't have to worry. I'm going to take 4 divided by that answer. And now I have this fraction in decimal form. And now what I'm going to do is I'm going to take the inverse sine of that. So inverse sine of the answer, so cut and paste, enter, and now I have my 49.11 degrees or 49.1 degrees. So P is about 49.1 degrees. Now that I mean, if I wanted to, I could play around, and after I did the decimal work with this, I could see if I wanted to try to do all of that with parentheses, how that would work. So 4 divided by, and then I would have to do 2 radical 7 in parentheses. So 2 radical, notice it opens up another set of parentheses. So close the radical, close the 2, close the inverse sine, and it does give me everything back the same way. So we do get that 49.1 degrees again. So it's just a matter of being careful with the parentheses. So if P is 49.1 degrees, remember Q is 90 minus that value because they're complements. And you have 40.9 degrees for the other one. So I did say that when you get the radicals involved, you want to be very careful. As I go back, I'm looking at this, and I will tell you if when we go further, because I said I do not want to make us go into all of the rest of the book, because I know some of us are trying to play catch up. Some of us still have questions on old material, and that's how pretty much here on out I will run the classes. I will ask if there's any questions first on past material, but then please understand I am going to continue to teach this chapter, and one of the things that I find interesting, and I have to be missing something, this problem can be done, but it's going to be done with either the law of sines or the law of cosines, and that means that instead of us having to rely on only right triangles with trig, our trig functions can actually be used with acute triangles and obtuse triangles. And there are rules that have to be followed and so on and so forth, but at least what we find out is we can solve. So I do apologize. I don't want us to sit here and watch me struggle with this, but if I figure this answer out, I will make sure that it is posted and that I show all of the steps, and I'll do it on a separate sheet of paper just so that if there's multiple things, it's not crowded in here without seeing the explanation. Sorry. They just probably broke a bush. Oh well. So if you have any other questions, type them in. Otherwise, this was all we were going to do today. I wanted to make sure that I answered your questions, so I appreciate the email that came. I just really wish I would have struggled with that late last night instead of this morning. That way I could have definitively given us an answer as to it can or can't be done at this point. So, are there any other questions? Nice. Thanks, Mr. Colahan. You want to help with number 16? All right, guys, if there are no other questions, I will work on that and I will get back to you in Google Classroom. And keep an eye out for any other assignments or directions, and we will talk again. Thanks a lot. And Mr. Colahan, I will be looking forward to that email because I am struggling. So I will talk to you guys all later. Thanks.